Imagine a world where your digital devices no longer sit on a desk or in your pocket but exist all around you, responding to your gestures, voice, and even your gaze. Imagine interacting with virtual objects as if they were physically present in your room. This isn't science fiction. This is the future of technology, and it's called spatial computing. Before we dive into spatial computing, let's first understand the technologies that led to it: virtual reality and augmented reality. VR is a fully immersive digital experience. When you wear a VR headset like the Oculus Quest, HTC Vive, or PlayStation VR, you're completely transported into a different world. Everything around you is virtual, whether it's a game, a training environment, or a virtual classroom. VR is widely used in gaming, training simulations, and even therapy. Companies like Meta, Sony, and HTC are continuously improving VR to make it more realistic and interactive. Real-world examples of VR. Gaming. Popular games like Beat Saber and Half-Life, Alyx offer fully immersive experiences. Training. Pilots, astronauts, and soldiers train using VR simulations before handling real-life equipment. Therapy. VR is used to treat PTSD and phobias by exposing patients to controlled virtual environments. Unlike VR, which creates a fully digital world, AR enhances the real world by overlaying digital elements onto it. You've probably used AR without realizing it. Think about Snapchat filters, Pokemon Go, or Google AR search results that let you place 3D objects in your surroundings. Real-world applications of AR. Navigation. AR-powered maps can show arrows and directions on your screen in real time. Retail. Brands like IKEA and Nike use AR to let customers preview furniture in their homes or try on virtual shoes. Healthcare. AR assists doctors during surgery by overlaying vital information on a patient's body. Now that we've covered VR and AR, let's take it a step further, into the world of spatial computing. Spatial computing integrates digital and physical realities even more seamlessly. It combines elements of VR, AR, artificial intelligence, AI, and the Internet of Things, IoT, to create an environment where digital interactions feel as natural as real-world interactions. Key features of spatial computing. Gesture recognition. Users can interact with digital elements through hand movements, much like how we naturally manipulate physical objects. Voice control. Instead of typing or tapping, users can issue commands and interact using natural language. Eye tracking. Devices can detect where users are looking, making interactions more intuitive and efficient. Environmental awareness. Using sensors and AI, spatial computing devices can understand and respond to the physical surroundings. Haptic feedback. Spatial computing can incorporate touch sensations, allowing users to feel virtual objects through specialized gloves or suits. 3D mapping and spatial anchors. Digital objects can be precisely positioned in real-world environments, making AR and VR elements more persistent and realistic. Real-world applications of spatial computing. Workplace collaboration. Companies are using spatial computing for virtual meetings where participants appear as realistic 3D avatars, making remote work more engaging and interactive. Healthcare. Surgeons can use spatial computing for detailed, interactive 3D models of the human body to assist in complex surgeries, reducing risks and improving precision. Education. Students can explore historical sites, dissect virtual organisms, or conduct physics experiments in an interactive 3D space, making learning more immersive. Smart homes. Devices like smart mirrors, interactive walls, and AI-driven home assistants will make daily interactions more seamless by adapting to user habits and needs. Manufacturing. Engineers and designers can visualize and manipulate 3D models of products in real-world environments before production, reducing errors and improving efficiency. Entertainment. Concerts, sports events, and theatrical performances can be enhanced with spatial computing, allowing audiences to engage in new ways, such as interactive holograms or real-time 3D overlays. Urban planning. City planners and architects can use spatial computing to create interactive, real-time models of cities and infrastructure developments, optimizing design and sustainability. Retail and shopping. Customers can experience virtual fitting rooms, where they can try on clothes digitally, or preview products in their home before purchasing, transforming the shopping experience. Automotive industry. Spatial computing is being used to create advanced driver assistance systems, ADAS, enhancing navigation, safety, and autonomous vehicle development. Military and defense. Armed forces use spatial computing for combat simulations, tactical training, and real-time battlefield visualization to improve strategy and safety. Space exploration. NASA and other space agencies are leveraging spatial computing to control robotic explorers, train astronauts, and simulate extraterrestrial environments for mission planning. The future of spatial computing. The future of technology is shifting from screens to spaces. With spatial computing, the way we work, play, and interact with the world is set to change dramatically. As advancements continue, we will see even more innovations that bridge the digital and physical worlds, making technology more immersive and intuitive than ever before. The integration of AI and IoT will further enhance spatial computing, leading to fully interactive environments where digital and physical realities blend seamlessly. In the coming years, we can expect spatial computing to revolutionize industries, redefine human-computer interactions, and create entirely new possibilities for innovation and creativity. Imagine a world where classrooms are no longer confined to four walls, where students can take a virtual walk through ancient Rome or explore the depths of the ocean from their desks. Picture a workplace where remote employees collaborate as if they were in the same room, interacting with 3D models and data in real time. Envision a healthcare system where doctors can practice complex surgeries in virtual environments before performing them on real patients, drastically improving precision and outcomes. As technology continues to advance, spatial computing will become more accessible and integrated into our daily lives. From smart glasses to holographic displays, we will see an evolution in the way we consume information and interact with the digital world. The possibilities are endless, and as researchers and innovators continue to push boundaries, we are only scratching the surface of what's to come. Spatial computing is not just a technological advancement, it's a paradigm shift. It will redefine how we interact with information, communicate with others, and experience the world around us. The fusion of physical and digital spaces will open new doors for education, entertainment, business, and more. As we move forward into this new era, embracing spatial computing will unlock unprecedented opportunities for growth, creativity, and human connection.
Radical novelty. Spatial computing radically transforms our interaction with the digital world by seamlessly blending physical and virtual environments, enabling immersive, context-aware, and intuitive experiences. Relatively fast growth. Relatively fast growth describes a quick expansion or development in a specific area, often surpassing previous rates or projections in a short time frame. Coherence. Coherence is the logical connection and consistency between parts of a whole, ensuring that everything fits together smoothly and makes sense. Prominent impact. The new technology had a prominent impact on the industry, transforming how businesses operate and interact with customers. Uncertainty and ambiguity. Uncertainty and ambiguity in the market make it challenging for businesses to plan effectively and anticipate future trends. Conclusion. Spatial computing represents a transformative shift in how we interact with digital and physical worlds, offering immersive, context-aware experiences that blur the lines between reality and virtual environments. Its rapid growth and potential impact across industries from entertainment to healthcare to education demonstrate its power to revolutionize the way we work, learn, and engage with technology. As spatial computing continues to evolve, it promises to reshape the future of human-computer interaction, offering new ways to visualize, collaborate, and experience the world around us. Building upon this, the integration of spatial computing and uniqueness in VR and AR doesn't just enhance individual experiences, it also reshapes how we interact with information, environments, and even each other. In spatial computing, devices no longer simply display data. They understand spatial relationships and can contextualize content based on a user's location, gaze, gestures, and physical surroundings. This spatial awareness enables far more intuitive user interfaces, such as gesture-based controls, holographic overlays, and voice-activated systems that respond not just to commands, but to context. It turns the entire environment into an interface, allowing users to interact with digital content in a natural, almost instinctive way. On the other hand, uniqueness within VR and AR is what makes these technologies meaningful on a personal and societal level. It empowers creators and developers to design experiences that adapt in real time to each user's needs. Whether that's a surgeon practicing a procedure on a simulated version of a specific patient's anatomy, or a student exploring a virtual reconstruction of ancient civilizations customized to their learning style. Uniqueness also fosters a sense of identity and agency within digital environments, allowing users to express themselves through customized avatars, spatial storytelling, or even the way they navigate and manipulate virtual spaces. Furthermore, as these technologies become more collaborative and networked, uniqueness extends into shared spaces, enabling multi-user VR and AR environments where each participant's presence and perspective is preserved and respected. This fosters richer, more authentic social interactions and opens up new dimensions for remote collaboration, education, gaming, and artistic expression. In essence, spatial computing provides the foundation, anchoring digital experiences to the real world in a meaningful, interactive way, while uniqueness gives those experiences depth.